Hello everyone, welcome back to Web3 tutorials presented by Nehemiah STEM Research. We are looking at Solidity in Remix Ethereum, and today we'll basically be continuing or picking up from where we left off yesterday, and we'll be continuing with transactions in smart contracts. And today I won't be looking at sending Ether in Solidity, so just like yesterday, but we'll be looking at transfer versus send versus call methods. So we'll learn today about the gas limits and behavior of transfer, send and call, how to properly set up a contract to receive Ether. So before we get into the coding demo, let's define a few things. Some are sort of like a refresher course from what we've been looking at over the course of this entire topic of Solidity. So one, what way is, and then gas. So let's start with these two. Way, to remind you, is the smallest denomination of Ether. Yeah, it's the smallest denomination of Ether. So 1 Ether is equal to way. So when sending Ether in Solidity, amounts are typically specified in way. And then gas is a unit of computational effort on the Ethereum network. So each operation costs gas, and sending Ether to an external address is an operation that costs gas. That's why when you've been looking at, let's say like in the previous tutorials, when you'd be typing code, you'd find at the end there like there's a gas icon. Yeah, so that's what that is. So with those two defined, we can then look at what re-entrancy attack means. It's a concept. Basically, let's say a critical security vulnerability where a malicious contract can call back into the originating contract before the first function call has finished. This can allow the attacker to drain funds if state changes, like updating balances. So it allows the attacker to drain funds if state changes happen after the Ether is sent, like updating balances. Yeah. The call method can forward enough gas for this to happen, which is why guards are necessary, which we'll define next. So we have what we call re-entrancy guard. It's a modifier or pattern that prevents a function from being called recursively before the first execution is complete. This is often implemented with a Boolean flag that is locked during execution. And of course, receiving Ether, for a contract to accept plain Ether transfers without calling a specific function, it must have either a receive function or a fallback function marked as payable. So that's it. We can begin our code demo. I'll type it out and then we'll break it down at the end. We'll go sort of like line by line. So I'll declare a contract called receive ether here.
check the WhatsApp, the group. You see Mr. Mike is communicating something. No WhatsApp. You guys are not working, or see now.
Haina option B. Hakuna tayari kole au wingo juu. Katika bank jeta. Utenge. Mali kupata kwa. Ya chata simani kadija sana. So ni kwenda basi.
Yeah?
Mr. Mike sent you a document detailing on what he wants us to do.
Mm-hmm.
In the WhatsApp, he just gave me one place. Now, even he was talking about the machines that we use. The machines are not here. And also we need to read through the document that he wants us to do.
You can just, remind him, tell him that we haven't yet got what you're asking for.
Talking about the SMS to voice. That one needs to be through the short code, and the short code is supposed to be this and you pay for it. That's the part. That's what I was asking. How about SMS to which group are you checking? The one that is there is a new report that shared yesterday way of but that one we don't have any what to do till next week. That has nothing to do till next week. Because we don't have data sets. We process it now. And that is for next week. What is the point also? That one is done. Just what is remaining is the short code. So that's what I'm thinking has been in that one. Let me think it's me. So I think I can go on the your machine is very strong to run it. It's not strong to run. No, what I was trying to say is to just pre-process it, to turn the JSON files into command sequences of that. Okay, he moved to. Yes, he did. So that will be for next week. So what was the goal? He asked to share the data set, but he was supposed to give us IP address so we can upload the data sets. He was going to provide. Until we upload the data set to the servers. So, going for the prototype file.
So this is it. This comment diagram is just to show you how to understand when the receive and fallback functions are called. That's why it's just a diagram. So we'll begin from line 22. We have a receive function. It's declared external and payable. So it's a special function introduced in Solidity version 0.6 and above. So external payable, so it must have these modifiers, external payable. So when it's called, this function is executed when Ether is sent to the contract and the transaction has empty message data, i.e. a plain Ether transfer without a function call. Then the fallback here is also a special function that is called when no other function matches the given function signature, or if Ether is sent with message data not empty. When it's called, it will either Ether is sent with data, or a function is called that doesn't exist. And then line 27, we have a function called getBalance. So it's a helper function to check the contract's Ether balance. And then of course line 28, return address of balance. So it gets the address of the current contract. The dot balance is the balance property, returns the contract's Ether balance in way. And then in the second contract, send Ether. So the first one was receive Ether. In the second one, we have a function send via transfer address to address payable to. So the recipient must be a payable address, then public payable, is the function itself is payable, so it can receive the Ether to be forwarded. And then transfer message value. First of all, to transfer. The transfer method is a built-in function for payable addresses. And then message value, the amount of way sent to this function. So the behavior, it forwards fixed 3,300 gas stipend. If the transfer fails, for example, the recipient is a contract that runs out of gas or throws an error, the entire transaction is reverted. This was considered safe, but is now problematic because 2,300 gas is often not enough for modern contracts. And line 40 function send via send. And there we have boolean. We've got send, then message value. To send, similar to transfer, but it returns a boolean, true or false, instead of throwing an exception. Behavior, similar to the previous one above, also forwards only 2300 gas. If it fails, it returns false instead of reverting. And line 45 require these we looked at yesterday, but we can explain. So that line manually checks the return value and reverts the transaction if send was unsuccessful. This makes send behave like transfer but with an extra step. In line 48, they have a function send via call. It has this from line 52. So of course this part is how you attach ether to the call. The empty bytes means we are not calling any specific function, just sending ether. This will trigger the receive function in the recipient contract. And then boolean sent. The call function returns two values. The first is a boolean indicating success. The second is any data returned from the function called. If we had called a function, that is, then we capture it in a variable data which we ignore. So that's why there's a space. Its behavior is that it forwards all remaining gas by default unless a gas limit is specified. This gives the recipient contract enough gas to execute complex logic, but introduces a risk of re-entrancy attacks. And then the last line 53 require send failed send ether is the essential check to ensure the transfer was successful. That's it. Now to interact. We need to find the sender Okay, so that's working. We can use any of the other functions, but let me first find it again. So 5, and then try another method. It has 6. Get balance. So this is in way, but you can see from up here it's 6 ether. Yeah, so any of these functions here can work. Let's see if I funded it again. 2. Yes. Transact. It's 8. Call that get balance again. So exactly. So that's it. That's how you send Ether in Solidity or between smart contracts with the transfer versus send and versus call methods or functions. Thank you for tuning in. Don't forget to like the video, subscribe to the channel, share it, and leave a comment as well. Have a blessed evening.